last part of part C. And I've been going rather slow and very thorough, I hope, so that you can get the technology as well as the principles used for figuring out uh, compound interest. We're going to warm up here with a language problem to structure and evaluate. How much money should be deposited? So in this case, we're looking for P. Present value. So this will be our zero. So we're going to say zero right here. What is deposited today in an account that earns 6%? So we've got our I percent to equal 6%. Compounded semi-annual, N is 2 for semi-annual. And it will be to accumulate 12,000. So then my future value is 12,000 in 3 years. My T is 3. We're going to put everything in zeros on anything we do not have an answer for. So our cap n is little n times 3. Our I percent is 6. We don't know our present value. We're not making payments, but we know our end balance. And we know that this PY and CY are semi-annual. And of course, when we get to it, we're going to do the alpha solve right here. All right. So let's look at what we can do. We're going to open our calculator. We're going to clear everything. Let me see if I make sure that you can see it. There we go. And now we're going to do our apps key, our finance section, and our TVM solver. And remember, you can clear it, but you've got to make sure that you can put an answer in there for it, or just type over it to times the 3. So I've got that. And then our I percent is 6. So I'm going to enter the 6 without changing for a decimal. 0, because we don't know how much to deposit in order to end up with 12,000. And then we're going to put in our future value 12,000. 12. Oops, I had put 100. Sorry about that. Let me go back one and delete it. 12,000. Good. And of course, it's semi-annual. The most important part is to make sure that CY and PY all have the same. Okay, we're going to move the cursor, the flashing cursor, to present value. We're going to do an alpha enter. All right. Now we said we had 2 times 3 for cap in, 6. Then we had 0. 12,000 was our desired amount in the 3 years that we put up there, 2 and 2. And our answer is $10,049.81. And I'm going to use the green. First, I'm going to write out what we see. All right, we know money is in 2 decimal places, so the amount we have to deposit is $10,049.81. Well, you wouldn't actually want to put specific cents, but in this program, they want the cents. You would have said $10,050 to ensure that at the end of 3 years, you have your desired amount. Okay, let's do another one, see what we're doing. Let me put that up. How much money should be deposited today? All right. So we want our present value, the amount we deposit. All right. So what else do they tell us? To earn 3.5%, so our I percent is 3.5, and compounded monthly. So our N is 12 for monthly. And let's see what else it says. To monthly, so that, a typo from your instructor, it will accumulate 10,000. So our future value is 10,000 in 4 years. Our T is 4. All right. So we have what we need for our calculator to calculate. Our N is monthly, 12 times the years, 4. Our I percent is 3.5. We don't change it to a decimal. We're looking for present value, 0 for payment, and we know our desired amount at the end of those 4 years. And that would be $10,000. And our PY and CY are monthly. Monthly. All right. And of course, we're going to come up here and do the alpha solve. All right. The alpha solve will give us that value. Now we're going to get our calculator. We're going to arrow up and type over, because I like to type over. 12 times 4. 3.5. 0 is what we're looking for. 0. And this one is 10,000. Make sure I put 10,000. Yep. And our N is 12. So we're going to move the flashing cursor to our present value and do the green tab, second row, first key, alpha, and enter for solve. And I need this amount, and it says 8,695 decimal 35403. And of course, we're going to round to cents. And what we did enter in the computer would be $8,995.35. All right, very good. So now we're really near the end, and so we want to talk about the reality of compounding interest. We've discussed that the size of the N makes the percent, or the parts of the percent value cut for each period. And that at the end of the period, we're earning a little bit more than what is stated because our principal is increasing. Remember, in simple interest, it was always a consistent amount of interest. So here, let's talk about effective annual yield. Effective annual yield, or effective rate, is a simple interest rate that produces the same amount of money in the account at the end of 1 year, as shown when the account is subjected to the compound interest in a stated form. What they're saying is, if we calculate this, use it to calculate 1 year. or the future value. And the importance of this is not going to give you exactly, but it's going to be doggone close. Doggone close. Because we're rounding. And in this class, we're using it as a method of knowing how much your money is working for you. All right. So we're going to take an example. You don't have a lot of these in the homework. The homework's not very large. The deposit 12,000 in an account that pays 1 41/100% interest compounded quarterly to find the future value after 1 year. All right. So we know that our present value is the 12,000. We know that our I percent is very small, 1.41, and that's realistic to our situation right now. Compounded quarterly, N is then 4 for quarterly. I'm trying to print so that nobody has difficulty understanding. And I'm sorry, I'm doing my best. Okay. And then we have compounding quarter, and we want it for 1 year. I should have put a T there, but you get it. Okay, so we're going to do it by our calculator because we understand that. So we're talking 4 times the 1. So we know that's 4. The interest rate is 1.41. Our present value is $12,000. 0, 0, and then this is our N, 4 for quarterly. We're going to do an alpha solve in future value. All right, so let's take care of our calculator. Okay, I'm going to move up in the N and put a 4, a 1.41. We're going to put our present value is $12,000. And 0 payment, 0 future value, and 4 and 4 for the quarterly. All right. And we want our future value. So we're going to go alpha, enter, alpha, enter. And I get this amount right here. Oh no, I did 1200. Sorry. Let me put a 0 there. Let me get up here and add a 0. Sorry. The answer was wrong. Garbage in, garbage out. $12,170.10 if we round it. All right. So we have our value of this, we're going to put it as $12,170.10. All right. So now we want the future value interest to determine the effective yield. Effective yield. So we're going to use our formula. Y equals, I need to be using a different color, sorry about that. 1 plus R divided by N raised to the N minus 1. Now here, R is used instead of I percent. That means it has to be in decimal form. So our item was 1.41%, and it changes to decimal 0.141. Move the decimal over 2 places, insert the 0. And then the N is 4. And we did it for 1 year. So we're going to say Y equals 1 plus decimal 0.141 divided by 4 raised to the 4 minus 1. And I'm going to make a little bit of room here. Oh, sorry, wrong move. Okay, so we need our home screen for this. And so I'm going to do a second quit to get to the home screen. Second, it's mode, second quit, and we'll get it. Clear will do it as well, I believe. I'm not sure though, I've never used it. I use second quit. 1 plus decimal 0.141 divided by that 4, close parenthesis, minus 1. So let me look, because you know, sometimes I'm thinking I'm typing correctly, but I don't. So I get this number, that our yield equals 0.001 plus 1 divided by, oh, I forgot that. Oh, sorry. I forgot the raised 4. I said, that's too big. Sorry. Way too big. We'll do it again. Open parenthesis, 1 plus decimal 0.141 divided by the 4, close parenthesis, up caret 4, go across and say minus 1. Now we got it. Sorry about that. So we get 0.141 747 blah blah blah. Well, we can only estimate what it would be, and so we have we had 2 decimal places, so we're going to go with 3. Okay, so I'm going to move my decimal over 1, 2, so I know it's 1.41, because that's what I started with, and add the 7 and do a percent. Always one more than the number of decimal places that you have. So, well, what does this mean? That's a percent. So, it says that if I take the 12,000 and I multiply by decimal 0.1417, I get I, because that's the interest that we would make. So let's do that. 1, 2, 1, 2, 3 times 0.0141, enter, and I get 169, 169.20. All right. Okay, so it's saying I'm going to have 169.20. So if I add it together, the 12,000 plus the 169.20, I'm going to get 12,169.20. And I'm off only by 90 cents. And that would give me exactly what the program gave. So that you can tell that you're earning a little bit more than you would have if we had multiplied it by the 0.014. So there you have it. Oh, it's 417. No, I did that right. Sorry about that. We're good. So that gives you an idea of how interest compounding works. We have this last problem, and it says an account has a rate of 2.5%. Find the effective annual yield semi-annually. So N is 2, R is 2.3% as decimal 0.023. All right. So our yield formula says it is 1 plus R over N raised to the N minus 1. And of course, we're going to enter what we have. And our N is 2, semi-annual, to the 2 minus 1. Don't forget that part. You saw that what happened with the first one. It just won't work. It'll give you an expanded number. All right, here we go. 1 plus decimal 0, 023 divided by 2, close parenthesis, up caret 2, go to the side minus the 1. And I get, okay, the more decimals you go, the more accurate it would be. But in this one, I only had one decimal, so I'm going to move over 2, so it's 2.31%. And we are done for this section. We're done for this section, I think. Yes. So I've learned our aptly refine it. And we'll be using it all the way through the end of this section. We've learned again that interest is the future value we calculate minus the present value of the initial deposit. And we learned that as well. And hopefully you can do this homework with ease. Thank you for listening, and do that homework.